Hello student, let us solve one problem. They are saying the density of a gas is found to be 5.46 gram per decimeter cube at 27 degrees Celsius at 2 bar pressure. What will be its density at STP? Right student. So that is we are having the they are asking that is D at STP, right student, D at STP. So D at STP, that is the temperature at STP is the 25 degrees Celsius, but in the Kelvin it will be that is 25 plus 273, that is 298 Kelvin. Okay. Now they are saying density of a gas, so normal condition if you talk about. So normal condition. So what are the normal condition that you try to check? D is equal to, they have given a student, suppose it is D1. So how much? 5.46 gram per decimeter cube given. At temperature T1 they have given a student 27 plus 273 means 300 Kelvin. Pressure they have given a student 2 bar. What will be density at STP? So, dear students, that we have to temperature is 298 Kelvin, pressure is how much student? 1 bar, right? These things are there. Pressure, temperature is there. Then they are asking the D2. They are asking density D2 at STP. So we, if you can divide student D1 divided by D2. So what we can write student? We know student PV is equal to nRT. This formula you know na. So P is equal to, we can do N by V RT. Okay. Now what we can write student? P is equal to N means W by V, and here is RT, and here will be M also. So it means dear student, that is P is equal to W by V means density, mass per unit volume. Right student, D RT by M. Right student, or you can say that is PM is equal to DRT. So D is equal to, what we can say student, PM upon RT. D is equal to PM upon RT. So dear student, PM upon RT. So PM, so let we have to write that is the value of the this M and other value also. So what we can do, dear student, M1 equal to M2, because the same gas is there. So we can write from the M1 equal to M2 from the ideal. See the read out the question. Density of a gas, same gas is there, found to be this much of the pressure. What will be its density? Its density means that gas. So that is the mass is the same, right student? So what we can write, that we are considering mass is 1, that we are considering suppose 1. So let us put out the value student. If you are putting out the values, so what will be coming up student? So that is we are writing the D1 value. So D1 if you are writing student, so that is from this equation, that is P1 M1 upon RT1. Okay, so this is D1 divided by D2. Here we can write P2 M2 RT2. So dear student, this M1 and same gas molecular mass is same. So M1 M2 is cancelled out. So what we can write, D1 is equal to P1 upon RT1 total divided by D2, and it is there R, this is the P2, this is P2 divided by RT2. R will be also cancelled out students. So what is left student? That is D1 upon D2 equal to, what will it be there student? P1 into T2 divided by, it will come T1 P2, T1 P2, right? So dear student, they are asking the density at NTP. So this is the D2 if you are calculating. So D1 into T1 into P2 upon P1 into T2, right? So density D1 they have given a student in the question. How much is given? 5.46. This is the density is given a student, 5.46. T1, T1 they have given 27 degrees Celsius means 300 Kelvin, and P2, so P2 that is STP pressure, so 1 bar divided by P1, so P1 is given already 2 bar, multiply by T2, T2 means STP condition, that is 25 degrees Celsius means 298. Okay, so now solve, student. D2 is equal to, if you are solving, student, how much the value you will get, let me check out the calculated value. It is 5.46 multiply by 300 multiply by 1, so it is coming, student, how much? 1638 divided by 298 multiply by 2, so this is 596. Okay, student, so 1638 divided by 596, so it is coming, student, 2.74. so D2, you can write D2, density at NTP is 2.74. so let me check out, student, what is the correct option. 2.74, option number third is correct, student. Thank you so much for watching, dear students.